In this video, we look at the solutions for the 2017 exam paper, question 3. In this question, we're working with a two-dimensional array. Before I start looking at the solutions for each of the questions, I want to quickly explain one important concept that's required in this paper. So let's assume that we have a two-dimensional array that contains 4 rows and 3 columns. So our cells positions is 1, 1, 1, 2, 1, 3, and in this case there'll be some number, maybe 10, 20, 30, etc. And 2, 1, 2, 2, 2, 3, and so forth. So when we run a loop, in order to go to each cell in the array, in a previous video, I would have explained to you that a nested for loop is required. We need 2 for loops. One loop controls the rows and the second loop controls the columns. And then when we refer to the array with R, C, in this instance, R remains fixed while C changes. And setting up the loops in this way takes us to each cell in the array, but it takes us 1 row at a time, meaning that the positions generated will be 1, 1, 1, 2, and 1, 3. So we go across a row. C finishes and then R increments to 2, and then we go 2, 1, 2, 2, 2, 3, and so forth. Let's look at a different situation where I swap my loops around. In this instance, I've got C from 1 to 3 on the outside, and then I've got R from 1 to 4 on the inside, and I keep my array still at R and C. So what's going to happen now is that the R is going to change whilst the C remains fixed. In the previous case, the C was changing whilst the R was remaining fixed. So we are generating cells. In this case, it's going to be R is going to be changing, so it'll be 1, 1, 2, 1, 3, 1. If I look at those positions, 1, 1, 2, 1, 3, 1, and because R is going to go 4 times, we'll eventually get to 4, 1. So what happens in this instance, when we go through the array, we are actually looking at positions that are now taking me down a column, as opposed to previously where we looked at positions that took us across a row. So in some of the questions in this paper, we needed to go across, in which case we'll structure the loops in this way. But where we need to go down columns, we will then structure the loops in in the way where we put the C loop first and then the R loop. Let's now go into the question. In this question, we've got an array, ARR departments. This is a one-dimensional array. It has 8 cells of type string, and these are predefined values. These are 8 different departments that are stored in this array. We then have another array, ARR sales. This is the 2-dimensional array. And you can see it in the declaration. It has 8 rows. You'll see here 1, 2, 3, 4, 5, 6, 7, 8. And it has 6 columns. So each value inside, 1, 2, 3, 4, 5, and 6. So those are the 6 columns, and we've got 6 columns for each of the rows, giving you a 2-dimensional structure. In question 3.1, we needed to display the contents of ARR sales. So we need to display this array that contains those values, but it also requires suitable headings. So we need these row headings, and we also need the column headings. That's week 1, week 2, week 3, week 4, week 5, and week 6. So we need to display that in a tabular form. So to get the first line of headings, department together with the weeks, this is the code that gives you the first line of headings. So we first need to start with department and a tab space. And then we run a loop from 1 to 6 because I want 1, 2, 3, 4, 5, 6, 6 weeks. I run a loop from 1 to 6, and I accumulate ARR weeks, R, and #9. Now, what is ARR weeks? ARR weeks is a declaration. It's a global declaration. So that is an array. That is an array that has 6 cells, 1, 2, 3, 4, 5, 6. So it has 6 cells, and it's of type string, and it contains week 1, week 2, week 3, week 4, week 5, and week 6. So this is an array that I created in the question called ARR weeks. So this array has been created, and I'm getting each value, and I'm just simply concatenating it. I'm joining it into the string called line, and that will give me this first line of headings. Once I've got that finished, I then display those headings, and then I start building in the other values that are required. First, I'm going to need the department name and then the values in the 2D array. I've got a string called str, and this string is going to accumulate all the values. Because it's a nested loop, because it's a two-dimensional structure, I need a nested loop. Here's my R loop, and here is my C loop, a loop inside of a loop. I then start off, here's my accumulator, str is set to nothing. I get the department, so R is 1, I get the first department. In this instance, it's PCs and laptops. So I get that department, and I store it in the variable str. Then I've got the C loop that's going to execute 6 times. 1, 2, 3, 4, 5, 6. Each time it's getting the value in the 2D array. It's getting the value from the two-dimensional array, which gets the value 1, 2, 3, 4, 5, 6. It gets those 4 values, it's converted to currency, and it's just accumulated in my string, and it's separated with a tab space. After that loop finishes, I need to take the cursor onto the next line. So I add a #13 into my string. In the 2016 paper, if you looked at those solutions I presented, instead of having a #13, I had my read out lines.add, I displayed str at that point, as opposed to accumulating the entire array. So you could have done that if you chose to. You could have had the output for that particular line and then go back up again, and then there would be no need to accumulate. You would then start with the new department name. But the way I've chosen to write the solution, I'm accumulating the entire thing into str, and that is printed at the end. I print it. So after the first time, I put my #13, a new line. I then go back to the loop. R then becomes 2. I then start working with row number 2, and I get the second department name, and then I leave. I go into 6 times, I leave a tab space, and I get the values from the 2D array. So this is just displaying all the values. At the end of the nested for loop, I display the entire array with the row headings. Remember that the column headings would have been displayed in the loop above. So this is how you would have answered question 3.1.